Namaste class, welcome again. Now let us see this sixth question. A circular park of radius 20 meter is situated in a colony. Three boys, Ankur, Syed and David, are sitting at equal distances on its boundary, each having a toy telephone in his hand to talk each other. Find the length of the string of each phone. So again, let us draw a circle first. Now there are three friends who are sitting at equal distances. So as they are sitting at equal distances, we will get an equilateral triangle. So something like this. Okay, so three friends, they are sitting at equal distance. Ankur, Syed and David. Radius is 20 meter. They have a toy telephone in their hand to talk with each other. We have to find the length of the string. So here this is Ankur, this is Syed and this is David. We have to find the distance between AS, SD and AD. So, and radius is given. So, radius, I will take this as center. This OA, O is center of the circle. So, I draw this AM. Now, this AM is going to pass through the center of the circle. This is the property of equilateral triangle. Okay. So, here I will say that given triangle ASD is equilateral triangle. This is an equilateral triangle. This is given. O is center of circle. To find, we have to find this distance AS. AS, which is equals to SD, which is equals to AD, is a question mark. OA, O is the center and OA is equals to 20 meter. Radius is 20 meter. Here we do a construction. We draw AM perpendicular to SD. Okay, and here solution. So, by property of solution, draw AM perpendicular to SD. Okay, we will do one more construction. We join OS. Also join or draw OS. Now, using, I will say that this AM will pass through center of circle and AM will bisect chord SD. We will say this is property of equilateral triangle. You can prove these things, but then this problem will be too lengthy. Okay, So I consider that as a property of equilateral triangle, that is this AM is passing through the center of the circle, and this AM is bisecting the opposite side SD, it is bisecting the chord SD. Okay, so therefore SM is equals to MD. So therefore you will say that this SM is equals to MD is equals to half of SD. Okay, this we consider as equation 1. Now OM we can consider as X, or let it be OM only. So we will not give any other name for that. Now in triangle, let us take triangle. Okay, before I will copy this and I will paste somewhere here. Okay, so in triangle OMS, now in this triangle I know the value of OS, it is 20, this OA is also 20, this OM I don't know, this SM I don't know. Okay, then I take triangle AMD. In this triangle MD I don't know, this AD. Now it is equilateral triangle, then AD is equals to SD. So here better in solution, first we will say that let this AS is equals to SD, AS is equals to SD is equals to AD is equals to 2A. Okay, this will help me. So this distance is 2A, this is half, so this will be equal to A. So this is 2A, this distance is A, this distance is A. So SM I know it is equals to A. OS I know it is equals to 20. OM I don't know. Okay, so OM you can take as X also, or keep OM as it is. So this distance is A, this is 2A. Fine. So now in triangle OMS, angle M is 90 degree by construction. Therefore, using Pythagoras theorem, we will say that OS square is equals to OM square plus MS square. Therefore, OS is 20. So 20 square is equals to OM we don't know, MS is A square, so A square plus OM square. Okay, so from this I can get the value of OM. Let us find the value of OM. It is equals to square root of this 20 square is 400 minus A square. Let us consider this equation as equation number 2. Now in triangle I have one more right angle triangle. In triangle AMD, angle M is 90 degree. Therefore here also we will apply Pythagoras theorem. It will give me this AD square is equals to AM square plus MD square. Therefore this AD square is 2A the whole square. This is equals to AM, so we don't know the value of AM, so it is AM square plus MD is A square. So here I have therefore AM square is equals to 4 times A square minus A square. This will give me 3 times A square. So the value of AM is equals to root 3 times A. Now AM is AO plus OM is equals to root 3 times A. Now OA is 20 plus OM. OM we got as root of 400 minus A square is equals to root 3 times A. So therefore I will say that this root of 400 minus A square is equals to root 3 A minus 20. So therefore I will square on both the sides. I will get 400 minus A square is equals to, I will square, so here it will become 3A square minus 2AB, so this is 40 root 3A plus B square, so 20 square is 400. Now this 400 and this 400 will cancel, so therefore, and this minus A square I will move on right, and this minus 40 root 3 I will move left. So I have 40 times root 3A is equals to 3A square plus A square. So that gives me 40 root 3 times A is equals to 4A square. So therefore I have 10 root 3 A is equals to A square. So this gives me the value of A as 10 root 3. Value of A will be 10 root 3 or value of A will be 0, but value of A is 0, not possible. So the value of A is 10 root 3. So I got value of A 10 root 3. Therefore SAS, therefore HD, first we will find HD. Therefore HD is equals to 2A is equals to 20 root 3. So therefore I will say that distance between each of them, what is asked in the question, how the statement is, find the length of string of each phone. So length of string, therefore length of string of each phone. So I will say that therefore length of string of each phone is equals to 20 root 3 meter. Okay, so length of string of each phone is equals to 20 root 3 meter. Now let us discuss few more concepts. Again I will take one circle. So let us take one circle. Okay, now in this circle, if I take chord AB and if I take a chord CD, and let us say that both are equal in length. Now if chord AB and chord CD are equal in length, then this arc length AB and arc length CD will also be equal in length. That means if I cut this AB and I will try to put it over CD, that CD portion will be covered by AB portion. Exactly, it will be covered by AB portion. That means when the chords are equal in length, then their corresponding arc will also be equal in length. Now we know that chords subtend equal angle at the center. Equal chords subtend equal angle at the center. So in the same way, what we can say that equal arc subtend equal angle at the center, and as angle between segments or as angle between segment is congruent, so in the same way angle between arc, angle subtended by arc, okay, is also congruent. So what I will say that if I have angle subtended by, say, let us remove this and again draw a circle and take an arc AB, say we take an arc AB, and this arc AB subtends some angle at this point C, which is in the remaining arc. Okay, AB, if I take arc AB, then angle ACB is angle in the remaining arc. Okay, now this angle ACB, and if I take any other angle in the remaining arc, let us say ADB. So angle ACB and angle ADB are going to be equal. As we know that angle in the chord, so if I take a chord AB, then angle subtended by this chord AB at two different points on the remaining part of the circle are going to be equal. Okay, so this we already know. In the same manner, the angle subtended by angles subtended by an arc, angles subtended by an arc in the remaining part of the circle are going to be congruent. That is, angle ACB and angle ADB are going to be equal. So this is your theorem. Angle subtended by an arc in the remaining part of circle is congruent. Okay. Now let us understand what is cyclic quadrilateral. Okay. So cyclic quadrilateral. Have you heard word cyclic quadrilateral? Now cyclic quadrilateral. Quadrilateral, we know it is a four-sided figure. Now when a quadrilateral's vertices are on the circle, then it is called cyclic quadrilateral. So I can draw quadrilateral like this. This quadrilateral ABCD is considered to be cyclic quadrilateral. Now if I join this DB and if I join this AC, what I get, that this angle ADB and this angle ACB are going to be equal. Okay, we know that arc subtend equal angle at the remaining part of the circle. So angle ADB and angle ACB are equal. So when it is cyclic quadrilateral, we see that these two angles are equal. So what conversely I can say that if there are two angles on the same side of a chord, if there are two angles on the same side of a chord and they are equal in measure, or I will say that if two angles on the same side of a chord are equal, are congruent, then those four parts, means two point A and B and the remaining 2 points C and D, they are all cyclic. So when there is a chord and there is two angle on the same side of chord which are equal in measure, then all the 4 points are cyclic, means all the 4 points lie on a circle. Okay, this is a theorem. When 2 points are on the same side of a chord, make or subtend equal angle, okay, then those 4 points are cyclic. Cyclic quadrilateral is a quadrilateral in which all the 4 points lie on a circle. Now there is a property of cyclic quadrilateral that opposite angles of cyclic quadrilateral are supplementary. So if I draw a cyclic quadrilateral, suppose this is my cyclic quadrilateral A, B, C, D, then angle D plus angle B is going to be 180 and angle A plus angle C is going to be 180. Now we can prove this. Angle D is angle subtended in an arc AC, or angle D is angle subtended by this major arc AC, and angle ABC is an angle subtended by this minor arc AC. Okay, so as the total angle at the center, if I see, then total angle at the center formed by this arc AC and formed by this minor arc AC, their addition is going to be 360 degree. So as central angle is 360 degree, sum of this angle and this angle is going to be 180 degree, half of it. So angle subtended at that center is always double angle subtended at the remaining part of circle. So as total angle subtended at the center is 360 degree, the angles, sum of angles are going to be 180 degree. So three theorems or three properties we have seen, that one is that if two angles are drawn on the same side of a chord and those angles are equal, then all the 4 points are cyclic. Second, we have seen that all the 4 vertices of cyclic quadrilateral are present on the circle. And third, we have seen that the opposite angles of cyclic quadrilateral are supplementary. Their addition is equals to 180 degree. Okay. Now let us solve few problems based on this. So this is our first question. Okay, in figure number 10.36, ABC are the 3 points on the circle. ABC, we can see ABC are the 3 points on the circle with the center O, such that angle BOC is given 30 degree, and angle AOB is given angle AOB is given 60 degree. If D is a point on the circle, D, you can see D is a point on the circle other than the arc circle other than the arc ABC. Okay, so this is outside this arc ABC. We have to find angle ADC. So what is the measure of angle ADC? So here in solution you can write whatever is given. Okay, in solution what you can say, that angle ADC is half the angle AOC. Okay, angle subtended by an arc at the remaining point of circle is half the angle subtended by the arc at the center. So here reason I will give angle subtended by an arc on the remaining part of circle is half the angle subtended by arc at center. Okay, now this angle ADC, so therefore your angle ADC is equals to half. Now this angle AOC is sum of angle AOB plus angle BOC. So this is equals to half of 60 degree plus 30 degree is equals to half of 90 degree is equals to 45 degree. So this angle ADC is 45 degree. Simple question. Okay, now let us see the second question. A chord of circle is equal to the radius of circle. Find the angle subtended by the chord at the point on the minor arc and also at a point on the major arc. So here I have a circle, let us draw a circle, and then I have a triangle. Better. Okay, I have a triangle. Actually triangle is not given. What they have given, okay, so let us erase this triangle, it is not there. Okay, what they say, that a chord of circle is equal to radius. So here I will draw a chord which is equal to radius. So suppose this is center O, the chord is AB. So here given this chord AB is equals to radius, that is equals to OA is equals to OB. This is given. I have to find the angle subtended by the chord at a point on the minor arc, also at a point on the major arc. So I will take 2 points, one at minor arc and one at major arc. So let us take one point here. Let us name it as D, point D. So this is one, and let us take another point, say C, D and C and D. Okay, fine. So I will get one angle, one angle like this. Okay. So C and D, I will say that C and D are points on major and minor arc respectively. Now this is given. What we have to prove or to find the angle subtended by chord at the point on the minor arc. Okay, to find angle ACB and angle ADB. Okay. Now in solution, I will say that as OA is equals to AB is equals to OB, triangle OAB is equilateral triangle. This OAB is equilateral triangle, therefore angle AOB is equals to 60 degree. So this angle is 60 degree, AOB is 60 degree. So angle AOB is 60 degree. Now angle ACB, this we know that this is half of angle AOB. Okay, angle subtended by an arc at the remaining point of circle is equals to angle subtended by arc at the center. Okay, reason I will say angle subtended by arc at remaining point of circle is half the angle subtended by arc at center. So therefore angle ACB is equals to half of 60 degree is equals to, I will get answer as 30 degree. So have you considered equation 1 somewhere? No? Okay. So this is my equation 1. Now angle ACB I got as 30 degree. Now angle ADB plus angle ACB, angle ADB plus angle ACB is equals to 180 degree. What we can say that opposite angle of cyclic quadrilateral. So therefore angle ADB. Angle ADB we don't know. Angle ADB plus angle ACB. Angle ACB we know. Angle ACB is 30 degree. Is equals to 180 degree. Therefore, your angle ADB is equals to 180 degree minus 30 degree is equals to 150 degree. So, angle ADB is 150 degree. Angle ACB is 30 degree. Angle ADB is 150 degree. Simple question. We have found these two values. Okay. So, let us stop here, and in next lecture we will see few more problems. Thank you for being with me.